All right, welcome to day 4 of review. Your homework will be to finish from page 14 to 19, whatever we don't do in the video. We will need our calculators out, so make sure you have those. And we'll start by going through number 8 from the homework. So one of the main topics from the homework was dilating a line. Usually it is centered at the origin. So what we want to do in that first equation, divide the 2 over, and we end up with the y equals 1/2 x plus 4. In the new equation, add the 1/2 x over, and we get the new equation of y equals 1/2 x plus 2. Because it's a different equation, we're guaranteed that the center of dilation was not on the line, so we don't have to worry about that. So just focus on the y-intercept. It went from 4 to 2. So the k value is just what it is multiplied by. So you might be able to just think about that and say, okay, 2 is half of 4, so k has to be a half. Or if you're unsure, think of it as 4 times some value of k equals 2. Divide both sides by 4 to get the k as 1/2. Going to the next one, number 1. So they showed a line segment dilated at that center P. You can probably just eyeball this one to see, but the choice 2 there, AB and A prime B prime were parallel. For 10, we're dilated, scale factor 4 centered at the origin. So the first thing we want to do is we want to test that point 0, 0, which is the origin. Sub it in for x and y and see if it gives us back a true statement. When we fill that in for x and y in our equation and neaten up, we get 0 equals -2. That is not a true statement. So because the center of dilation is not on the line, it should create a parallel line. So we're looking for the options that have the same slope, which would be choices 1 and 2. Of those, now do the center of do the scale factor of 4, multiply your -2 by 4, and you get the -8. It would have been choice 2 if the center of dilation had checked out. Because if the center of dilation is on the line, the equation is just the exact same line. So we would have had same slope and same y-intercept. But because it didn't check out, we'd have a parallel line which should have a different y-intercept. Another topic from this day was our proportions within right triangles. Remember, we want to draw our small, medium, and large triangles. In this one, we're just looking for a proportion that could be set up. So in choice 1, they gave us AD over AC. So based on that, for this proportion to be correct, we would need something from the small triangle matching something in the same spot in the big triangle. So they started with CD. So that would need to match with BC, and that is what they gave us in the choice. In our next one, we've got another dilation of a line. So start out, take our origin, 0, 0, sub it in for x and y. And that's what I'm showing right above where I just wrote. So we end up getting 0 on the left, 8 on the right when we neaten it up. That's not a true statement, so therefore we're going to be looking for a parallel line. If it did work out, if we got like 0 equals 0 or 7 equals 7, then we would be looking for the exact same line. Parallel lines have the same slope but different y-intercept. So let's take our original equation and let's work to get y by itself. So over on the right there, I added the 3x over and then divided by 4. So this is our current equation. So we want the same slope, but we want a different y-intercept to be parallel. There was only one choice that even had the same slope, so it was choice 2. Next one, we're back to our proportions in the right triangles. I labeled RQX because that's what we wanted to look for eventually. Draw your small, medium, and large ones oriented the same way. The medium and the large are the ones that have matching sides to set up our proportion. So I did the 15 hypotenuse over the 17 hypotenuse equals the x leg over the 15 leg. Cross multiply and solve, and then to the nearest tenth we have 13.2. Next one, I reoriented that first triangle so it matched up. So our missing angles we could find by subtracting from 180. So A was 29 and S was 61. That allowed me to know that when I rearranged it, that the A should be up like the R and the S and the B should be over to the right like S. So this one we're looking for a proportion that's not correct. So if we start with the first option, we've got AB, which is a hypotenuse, over RS, which is a hypotenuse. So if this is going to be correct, the right side of the proportion should be something from ABC matching something from RST. Well, the next one they gave us was RT. So it's not even coming from the correct triangle to be set up properly. So that's why one one is our choice that was not a correct proportion. All right, in 10, I drew my three triangles oriented the same way. The values you can see there are the ones that were given in the problem. So the first thing I did, because there was not enough information to find x as it currently was, I did Pythagorean theorem in the small triangle to get that IK was 15. So we now have 15 as that hypotenuse and 15 as the short leg in the huge triangle. Well, now that we have those values, I chose to do, you have two proportions you could set up now, or two triangles you could use. I chose to do the small and the medium. So I did the 15 hypotenuse from the small over the x hypotenuse from the medium equals the 9 short leg from the small over the 12 short leg from the medium, cross multiplied and got 24x. You also could have done the small and the huge. You could have done like 9 over 15 equals 12 over x, and that would have given you the same idea. For 24, another dilation one, sub in our center of 0, 0. We got 0 equals -4. Not a true statement, so we're looking for a parallel line. If it did give us a true statement, we'd look for the same line. So our options are 3 and 4 for parallel lines. Now, I showed how to find the specific y value by multiplying, or the y-intercept by multiplying the -4 by 3/4, but we also just know it needs to be a different y-intercept, so that could have told us it was choice 4 as well. All right, so our new stuff for today that we're going to review is our right triangle trig. So two things we need. We need you to take your calculator out, and we also need to go to our calendar packet and flip to page 7. So if you could take a moment to do that now. Now, when you have your calculator, go to a calculator page. Up in the top right where the battery is, we need to make sure the top right says DEG for degrees. Notice mine right now says RAD, which stands for radians. That's something you'll use next year. We need it to say degrees. So just take your arrow and click. If it said RAD, click it so it says DEG. We want DEG, so make sure it says DEG there. When we get you set up for on the Regents exam, I'll be up at the microphone, and I will make sure that everyone is in DEG, and we'll have you raise your hand if you're not. But this is important for our sine, cosine, tangent problems to be in degree mode. Okay, so in our calendar packets, so review of some of the topics. So first off, SOHCAHTOA, you want to be comfortable with how to spell it, because if you can't spell it, then you can't actually use it. What does the SO represent? That means that sine is always the opposite over the hypotenuse. The cosine is adjacent over hypotenuse, and the TOA, the tangent, is the opposite over the adjacent. That is all in relation to whichever acute angle you are working with. So if we go over to the right side of the page, on that top triangle, imagine we're starting from the acute angle that's marked. If you go through the triangle, that takes you to the opposite side. The adjacent is the one that is next to but not the hypotenuse, and hypotenuse is always across from the right angle. Notice in the triangle below that, if we switched acute angles that we're working from, now the opposite and adjacent have switched, but hypotenuse stays the same. So always determine which angle you're working from first and then label the opposite, the adjacent, and the hypotenuse. When you're finding a side using a right triangle, the angle always goes after the sine, cosine, or tangent. And then you set up either your opposite over hypotenuse, adjacent over hypotenuse, etc. So here's two examples of our equations that have already been set up when finding a side. When we want to then solve finding a side, we put our trig function over 1 because it's really just a number, and any number can always be put over 1. And then we just cross multiply. Well, 1 times x would give us x, and then we'd have whatever 12 times sine of 43 is, and we would end up putting that in the calculator, and the question would tell us where to round. Well, if we go to that second equation I have there, if we put the sine 57 over 1 and cross multiply, 6 times 1 gives us 6, and then we'll have y times sine of 57. Well, notice in this scenario, cross multiplying didn't get the variable by itself. So we've got to do one more step still. We can undo multiplication by doing division. So we would divide both sides by sine of 57. So now y is going to equal 6 over sine of 57. We would now put that in the calculator and round to wherever they wanted us to round to. So when you're finding a side, you just cross multiply and keep working until you have x by itself. When you're finding an angle, again, notice the angle always goes after the sine, cosine, or tangent. So in this case, our angle is missing. When you find an angle, that's where you do your inverse of your trig function. Our next step here, we would just have x equals, and we would do the sine with the -1. And then in the parentheses just goes 5/7, and we would end up putting that in your calculator. The sine -1 just stands for sine inverse. And if we go just to look at our calculator for a second, the trig button, remember, is right next to the 7. So if I hit that, notice the top row you have your regular sine, cosine, tangent. The bottom row you have your inverses. So the top row are the ones we use when we're finding a side, and the bottom row are the ones we use when we're finding an angle. I don't know if I put this on your notes packet or not. If not, if you could add this on, this part in the box here. If you have a right triangle, and let's say A and B were the acute angles, sine of A will always equal cosine of B. And the reason for that, if you go from A, the opposite is this side, and the hypotenuse is this one. Well, if you do cosine from B, the adjacent is this side, and the hypotenuse is that one. Well, notice they use the same sides, so that's why sine from one acute angle will always equal cosine from the other one. So again, if you could be adding what we have written there on kind of that little box on the board if it's not already in the packet. And the other thing that they sometimes test with that idea is in our right triangle, we've already used 90 of the degrees for the right angle. So the remaining two acute angles are guaranteed to always add up to 90 degrees. So like if they told you that we had sine of x plus 10 is equal to cosine of like 2x plus 5, let's say, because sine and cosine are equal, we know that those angles must add up to 90. Because if sine and cos are equal, it's really just working with the two acute angles in the right triangle. So we would just do x plus 10 plus 2x plus 5 is equal to 90, and then we would go through and solve. So they tend to ask that. It's usually in a multiple choice question. Now there's one other thing that we saw in these units, the law of sines. We're just going to show it to you when we get to a problem that uses it in the video today. It's usually used in problems that have two triangles within the problem when they're sharing a side. So you can keep this packet out so you can reference to it, but we're gonna go over to our problems packet now, and we're gonna go to page 14 in that problems packet. Now just remember the page numbers are in the top left of the page, and it should also say day 4 on that top left as well. So for this first one, notice we've got a sine and a cosine equal to each other. So this is what we just talked about, that if sine and cosine are equal, it's guaranteed that the angles together should add to 90 because they are the two acute angles in a right triangle. So we'll have 4x plus 3x plus 13 is equal to 90. If we subtract the 13 over and combine like terms, this will give us 7x is equal to 77. And if we divide by 7, we get x equals 11. Always, always, always on this test, do not circle your answer when you get a variable. Reread the question, see if that variable is what we wanted or not. Our question asks us to find the number of degrees of the smaller angle. Well, one of the angles was 4x, the other one was 3x plus 13. So we do not want to circle 11 for our answer. Notice they have it as a distractor choice because they know they're going to get a certain number of people to just automatically circle that. So what we'll do is we'll do 4 times 11, see what that gives us, and we'll do 3 times 11 plus 13. We'll see what that gives us, and whichever of those is smaller is the one we'll choose. So we'll give you a moment to punch those in your calculator now or to do them in your head and see which one gives us the smaller. So we should get 44 for this one, and we should get 46 for the other one. So 44 is the smaller one. Now, a couple test taking strategy things. 4 couldn't possibly be the answer because if the two angles are going to add up to 90, if 52 is one of the angles, the other angle that adds to 90 with it has to be the smaller of the two. Probably, my guess is one of the other distracted choices is what you would get if you had set them equal, because the 13 is what you would have gotten if for x if you had set them equal, and probably 52 is what you would have got back as a smaller of the two. So that's where those incorrect choices are coming from. All right, next one, 33. Take a minute, see if you can read through the paragraph above and what they are asking for below the picture. All right, so in the long run, we want to find the length of the ladder. We've got two triangles going on in this picture. So this triangle here, and I'm going to redraw it off to the side. We know we've got a right angle, we've got 56 degrees, and the bottom side should be 1.3 meters to match that 1.3 meters that is on the bottom. The other triangle that we have is this big one here that involves the ladder. The things we know about this triangle, we know 1.3 meters for the bottom side. And for the vertical side there, we know this portion of it is 1.5 meters, but we don't know the other portion. but the other portion is coming from the vertical portion of our purple triangle. So I'm going to call the purple vertical part x. So that means that this vertical portion in the green is going to be x plus 1.5. And then what we want to find eventually, the length of the ladder, is the hypotenuse in the green triangle. So I'm going to go ahead and label that y. And what I'm going to do is next to where it asks us the actual question, I'm going to write y just as a reminder that the y is really going to be our answer. So what we're going to do is we're going to work with the purple triangle first. We're going to start from the 56 degrees. If we go through the triangle, the x is our opposite and the 1.3 is our adjacent because it is next to and it is not the hypotenuse. So we're going to do tangent using SOHCAHTOA. So we're going to have tan of our angle 56 is equal to our opposite x over our adjacent of 1.3. It's finding a side, so we're going to put the tan 56 over 1 and we'll cross multiply and work through to solve for x. The 1 times x gives us x, and going the other way we have 1.3 times tan of 56. So go ahead, put in that 1.3 tan of 56, but keep in mind that's not our final answer, so we're not going to want to round it. You never round until your very final answer of the problem. So we'll give you 30 seconds, see if you can punch that in. So we should be getting 1.927 and change for that. Well, to get the vertical side in the green triangle, we want to add the 1.5 to that. Now notice this dot, dot, dot that I'm putting. That will signify to the grader that you're keeping the number all the way out in your calculator, which you want to do. You do not want to round any intermediate answers. So let's take our answer that we have in the calculator currently, and let's go ahead and add 1.5 to that, and we'll give you 10 seconds to do that. And that should give us 3.427 and change. We'll put the dot, 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 again to show the grader that we've kept that all the way out. So I'm just going to quickly redraw our green triangle. We're looking for the y. We've got the 1.3 meters. And now we know this vertical is 3.427 dot, 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 dot. And here's our right angle. Well, we know 2 of the 3 sides in this right triangle. We do not know any angles, so we can just do Pythagorean theorem. So we're going to do 1.3 squared plus 3.427 dot, 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 all squared, and then equals y squared. Now we want to make sure we carry down the entire thing. So let me just get that on my calculator page. So we had the 1.3 times tan of 56, and then we added the 1.5 to that. So when we put this in our calculator down to do Pythagorean theorem, we're going to do the 1.3 squared plus, and then you can scroll up and highlight the 3.427, the entire thing, hit enter to bring it down, and then put your squared on it. So we're going to get 13.436 and change. So we'll put the dot, dot, dot to show we're keeping it out. And we'll take our square root of both sides. And we'll give you a moment to do that on the calculator now. A reminder, the square root is above the x squared, which is right next to the 4. So do control and then the square root. And again, scroll up and highlight it. Hit enter to bring it down. You can also do your hotkeys like control C for copy and control V for paste. That would work as well. So when we put that in, we get 3.665 and change. And now this is our final answer, so this is where we round. We wanted to the nearest tenth of a meter, so we're going to have 3.7 meters. They will always tell you what the units are in the question. So you shouldn't have to guess. They'll tell you what the unit is that you're rounding to. So just read the question. It'll always say that. All right, going to our next one, which flips to the next page, number 22. We'll give you 15 seconds to read the question. All right, so here's our building. Here's our window. And here's our picture that we got going on. So 12-foot ladder, so that's this part, 10 feet above the ground. And we want to find the angle with the ground. So I'm going to call that X. From the angle, the 10 is our opposite. The 12 is across from the right angle, so it's our hypotenuse. So we're going to use sine. So we'll have sine of the angle X equals our opposite 10 over our hypotenuse of 12. We're finding an angle, so in the long run, we're going to do our inverse. So we'll now have X equals sine inverse, and we just put our 10/12 in the parentheses. So go over to a calculator page, do your trig button, and we're selecting from the second row the sine inverse, and then put that fraction in. And we'll give you a moment to do that in your calculators. And we should be getting that X is 56.44. So to the nearest degree, we've got 56 degrees. All right, moving over to the next one, we'll give you 45 seconds or so, see if you can read that paragraph and what it talks about down below. Okay, so everything's labeled for us in the picture. We want to find X eventually. Notice we've got two triangles together that are sharing a side. So in this type of problem, the easiest way to do it is to use what's called law of sines, which is something we saw during this unit. Law of sines, you take sine of some angle over the side across from it is equal to sine of another angle over the side across from it. Now, what's nice about law of sines is it can be used in non-right triangles. That little triangle up above is a non-right triangle, which is why we might want to use law of sines in this case. When you see these double triangle problems, often what you do is you end up finding the side that they share first. So I'm going to call the side that they share Y. And let's go ahead and find all the angles in our problem. So first let's work with the bottom right triangle, the one that has the 30 degrees and the 440. Well, since we have 90 and 30, this leftover angle has to be 60. Based on angles on a line, the angle right next to the 60 must be 120 because they have to add to 180. If we go down to that tiny little angle, if the whole thing including the 30 is 38.8, that means this little angle has to be 8.8 degrees. And then we could just take the 120 and the 8.8 away from 180. And that'll give us 51.2 for this remaining angle. So what we're going to do is we're going to start with the bottom triangle. that has the 440 in it. We'll find the side they share using law of sines, and then we'll do law of sines again to find the smaller triangle. So working with this bottom triangle here, we want to make sure that y is involved, and we'll also have to use the 440. So in this bottom triangle here, the 60 degrees is across from the 440. So we're going to do sine of 60 over 440 is equal to, and we want the y involved, so it's across from the 90. So we'll do sine of 90 over y. So we're going to cross multiply and solve for y. So we have y times sine of 60 equals 440 times sine of 90. And to get the y by itself, we'll divide by sine of 60. So we're going to have 440 times sine of 90 all over sine of 60. Now, when we put that in, I would suggest to use our fraction template. So let's do control divide to get the fraction template. We'll have 440 times sine of 90. And if you move down to the bottom, we can do our sine of 60. And we get 508 and change for that. Now we do not want to round this because it is an intermediate answer. It's not our final answer. So we got y equals 508.06 ... Well, now we're just going to go to the second triangle, that top one. We'll do law of sines again because we now have this y value. So we're going to do sine of 51.2 over that 508.06 ... equals, now in this top triangle here, the x is across from the angle of 8.8. So we're going to have sine of 8.8 over x. And now we're just going to cross multiply and solve. So we'll have x times the sine of 51.2 is equal to that 508.06 times the sine of 8.8. We're going to divide both sides by sine of 51.2. So that means x is just going to equal that intermediate answer that we had times sine of 8.8 over sine of 51.2. So if we go back to our calculator, I'm going to do our control divide so we get our fraction template. I'm going to scroll up and get that whole answer there. We're going to do times the sine of the 8.8 over, then we had the sine of the 51.2. And so we get back 99.73 and change. And if we check where we want to round to, they want us to round to the nearest foot. So the 7 after the decimal point bumps us up. So 99 will get bumped up to 100 feet. All right, if we go over to the next question, 17 over on the next page, we want to know which one would give us the value of A. So starting from A, notice this is our adjacent and this is our hypotenuse, so this would be opposite. Well, using this ones we have, adjacent and hypotenuse would be cos. So we could do cos of angle A gives us 8 over 17. Well, notice the cos of A1 was 15 over 17, so that's ruled out. So what we can do is we can do Pythagorean theorem to get that missing side. So we can do 8 squared plus b squared equals 17 squared. That'll give us 64 plus b squared equals 289. If we subtract the 64 over, we'll get b squared equals 225. And taking the square root, that gives us b equals 15. So other options we could do from a, if we did sine of a, we would do opposite over hypotenuse, so 15 over 17. If we did tan of a, we would do opposite over adjacent, so 15 over 8. So we'll see if one of those is an option. So sine of a, they said was 8/17, so that's no good. Tan of a, we have 15/8, so that's our one we want, choice 4. All right, moving over to the next one, 34. We'll give you a minute to read through this question. So because we want to find the length of the ramp, this is really the triangle that we're working with here. So I'm going to redraw that triangle down here. And they told us that the angle is 4.76 degrees. Now we eventually want to find the ramp, so I'm going to call it x. There's something we need to be careful about in this question. We want to find x to the nearest foot, but they gave us these measurements in inches. So this vertical height here is this 6 inches, this 6 inches, this 6 inches. Well, each 6 inches is 0.5 of a foot. So altogether, this is 1.5 feet. We'll add that in our picture down here. Now, the bottom side of our triangle is D, and then we've got two of these horizontal amounts. Well, there's 12 inches in a foot. So 8/12 reduces to 2/3. So each of these is 2/3 of a foot. Together, that gives us 4/3. So we're going to label this bottom side as D plus 4/3. And for simplicity's sake, let's consider this bottom side Y. And that'll eventually come into play in the second part of the question. Now, we're not going to do this whole thing in this video, but we'll help you set it up. To find x, we've got from the angle, the 1.5 is opposite and the x is hypotenuse. So we can just do a sine of 4.76 equals the 1.5 over x. And then you can work to find what the ramp height is. Once you have the ramp height, you can just do Pythagorean theorem to find y. You'll do that x squared should be equal to 1.5 squared plus y squared. And you'll just take your answer for x and put it in here. Once you find y, though, you'll have to subtract the 4/3, and that'll give you what d is. Make sure when you do the x in the second part of the question, you keep it out all the way. Don't use your rounded answer. And that's how you would go about finishing this question. So you've got the rest of the day 4 stuff to finish off for homework. Have a good rest of your day.